Hello kids, I hope these are going okay for you. I'm recording, trying to get as many as I can done before we start other meetings, and then I'll adjust if we need to after we start them. So this is a third one in chapter 9. This is 9.6, solving right triangles. I hope the sine, cosine, tangent went okay for you. Put that out there. So what we'll mainly look at here is when you know the lengths of the sides of a right triangle. So now you know the sides. How can you find the measures of the two acute angles? So now, given the sides, find the angle measures. So that is a little different than what we had the last two lessons. They were giving us a side and an angle measure, one of the acute ones, and then we could find the other sides. But now if we have the sides, can we find the angle measure? So we're kind of going backwards. Okay, lately Daniel's been enjoying doing things backwards, and he turns around and tries to do it. So let's do it backwards. So what we have to do that is what we call the inverse tangent, the inverse sine, inverse cosine, and then what it means to solve the right triangle. That is just to find all the angle measures and side lengths. That's what it means to solve a right triangle. Find everything about the triangle. So these inverse operations are used to find the measures of the angles. So if you know the sides, so let's say this is side X, side Y, and side Z. So if I'm finding the tangent of A, I want to find that. Remember, tangent is opposite over adjacent. So if you do this inverse ratio, so tangent with the -1, if you take y divided by x, then that's going to be what the angle A is. Okay? So y over x would be the tangent. Sine is SOHCAHTOA. Sine is opposite over hypotenuse, so this would be the inverse sine of y over z would be the angle A. Cosine, SOHCAHTOA. Cosine is adjacent over hypotenuse, so that'd be x over z. That also equals angle A. Okay, so the inverse functions will tell us the angle measure when you know the side lengths. So inverse functions will tell us the angle measure when you know the side lengths. On your calculator, these are a lot of times secondary functions. So hopefully you can see, here's my sine, cosine, and tangent. If you look right above it, you see sine to the -1, cosine to the -1, tangent to -1. Those are the inverse functions that we'll be using. Remember, inverses undo what we did before. So if a sine tells us the side lengths, the inverse sine will tell us the angle measures. Okay, so practice. There's what it means to solve a right triangle. Find all the unknown side lengths and angle measures. Okay, so it says, determine which of the two acute angles has the given trigonometric ratio. Forgot to pull up this assignment, make sure I cover everything for you. Okay. So they say the cosine of the angle is 24 over 25. So 24. So now we know that cosine has to be adjacent over hypotenuse. So 24 over 25. 25 is the hypotenuse. 24. For which angle is 24 the adjacent side? So for which angle is 24 the adjacent side? That's the key question here. So 24 is down here, which means angle F would be the adjacent side here. So which of the two acute angles has the given trigonometric ratio? F has a cosine of 24 over 25. So you'd say the measure of angle F. Okay, let me check, see how those are put in. Okay, that's loading. We'll go over this. The sine of the angle is about 0.38 Ooh, so they're doing a decimal, and we have square roots here. So I'm going to check this. So sine. Sine I know is opposite over hypotenuse. So does root 2 over 2 root 3 equal 0.38? Or does root 14 over 2 root 3 equal 0.38? That's what you got to check. Oh, wait, what am I doing? That's the hypotenuse. Come on, Mr. Leitner. Still the end of the day, I haven't gotten home yet. Okay, so root 2 over root 14, or does 2 root 3 over the square root of 14? Which one of those? So here I'm checking, okay, so if I want sine, this would be opposite over hypotenuse, root 2 over root 14. Or if I'm over here, if I want sine, I would go opposite, root 2 root 3 over root 14. So which one of those worked? So I'm going to check square root of 2 divided by the square root of 14. That is about 0.38. So it should be this one. This one should be the opposite side. Let's just check 2 root 3 divided by the square root of 14, 0.925. So yeah, this is not the opposite side. This one has to be the opposite side, which means we are finding angle E. Okay, and you just type in the letter on your assignment. So just type E, you don't need the measure of angle. Okay, let H be an acute angle. Use a calculator to approximate the measure of angle H to the nearest tenth of a degree. So the sine of H is 0.2. So you're just going to do the inverse sine of 0.2, and that's what H is going to be, to the nearest degree. So it's a secondary function. I'm going to go shift that and 0.2, and we get about 12 degrees. Nearest tenth of a degree, 11.5 degrees. Okay, using the calculator. Tangent of H is 1, so we'll do inverse tangent of 1. That would equal H, so shift tangent 1, 45. I knew that one. Okay, cosine H is 0.33, so we have to do the inverse cosine of 0.33. That's going to equal H. And that is 70.7 degrees. So you're ahead of me a little bit. .89, so 62.9 degrees. Okay. Those you just plug it in. A lot of solving is what you're doing here. So let's get to the solving of a right triangle. Okay, so solve the right triangle, round decimal answers to the nearest tenth. You notice you have two sides. You can do the Pythagorean theorem to find the third side. That's hypotenuse. And you could say, okay, I know a squared plus b squared equals c squared. C has to be the hypotenuse. So c is the square root of a squared plus b squared. So square root of 6 squared plus 12 squared. We can round it to the nearest tenth. So square root of 6 squared plus 12 squared. 6 root 5, which is about 13.4. So AC is about 13.4. So from A to C, it's the length from A to C. And you'll have to find each of these. They will have boxes for you in there. And you just have to say what it is, each distance is. Okay, so if I want to find angle A, I know the opposite side, and I know the adjacent side. Again, I'd use the numbers that are exact. I would not use the rounded answer. So opposite over adjacent, that is tangent. So I'm going to do inverse tangent of 12 over 6. Whenever you're looking for an angle, remember you use the inverse functions. Okay? So I'm looking for an angle, 12 divided by 6. Okay, I could just put 2. And I get, that's A, so the measure of angle A is about 63.4. That's 90. This other one, remember those two are complementary. The measure of angle C is going to be approximately 90 minus 63.4. That's going to be about 26.6 degrees. Okay, 26.6. So that piece of information, that is what you need. Okay, that would be solving the triangle. You found the missing side, and you found the two measures of the two acute angles. Okay, so here, this is the hypotenuse. So this side is going to be the square root of 75 squared minus 21 squared, Pythagorean theorem. But you're looking for a side now, so you take that squared minus that squared. So 75 squared, 72, really? Okay. So E to D equals 72. E to D, 72. There's your first part. Okay, if I'm looking for C, I want the measure of angle C, and I also need the measure of angle D. So C, the 21 is the adjacent, 75 is the hypotenuse. Adjacent hypotenuse is going to be cosine, so I'm going to do inverse cosine of adjacent over hypotenuse, 21 over 75. 75, about 73.7 degrees. Okay. And then D has to be the complement, so I'm going to take 90 minus that answer and get 16.3 degrees. Okay, pause these, try these on your own, do that, and I'll keep working here. Okay, so they give you a side and an angle. So now we have to start off with the trig to find the other sides. We don't have the two sides. So this is the hypotenuse side. If I want to know this side, that is the adjacent side. Adjacent hypotenuse is cosine, so the cosine of 52 equals x over 3. So x equals 3 times the cosine of 52, which is approximately 1.8. So L to M equals 1.8, or it's approximately 1.8. So this one y, that's y, that would be opposite. So the sine of 52 would equal opposite y over hypotenuse, 3. So y equals 3 times the sine of 52. 3 sine 52 is 2.4. That would be MN. MN is about 2.4. Angle N would be 90 minus 52. So that would be 38 degrees. The measure of angle N is 38. MN I got to be 2.4 and then 1.8. Okay, 29, that means this is 90 minus 29. Let's get this straight for you. There you go. That's 61 degrees. So 18 is opposite, or you can use a 61, it'd be adjacent. So if I want this is the adjacent side to my 29. I have to use tangent. The tangent 29 degrees is 18 over xz, that length. So xz equals 18 over the tangent of 29, which is about 32.5. I want yz, that's the hypotenuse. Opposite over hypotenuse is sine. So the sine of 29 degrees, going back to the 29, sine is opposite over hypotenuse. Opposite, which is 18 over yz, the hypotenuse. So yz would equal 18 divided by the sine of 29, which is 37.1. And that. Okay. The boat is pulled in by a winch on a dock 12 feet above the deck of the boat. When the winch is fully extended to 25 feet, what is the angle of elevation from the boat to the winch? Angle of elevation from the boat to the winch. They want that angle right there. This is an angle of depression. This is the angle of elevation. So we have the opposite side and we have the hypotenuse, because there's your 90-degree angle. So opposite hypotenuse would be inverse sine, opposite over hypotenuse, which is inverse sine 12 divided by 25, 20 about 28.7 degrees. Okay. And then 9.7, we have one more section in chapter 9. But I hope the trig is going okay. I think it's kind of fun to figure out some of these triangles. It's not always easy, but as long as you remember your ratios and your formulas and where those parts plug in. That's kind of the trickiest thing, is which one do you sine, cosine, tangent. Make sure you're going opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and that will help a lot if you can remember those ratios. So good luck. Let me know how I can help you, and stay Bluebird strong.